Welcome. Today, we're turning our eyes toward the stars, but we're keeping our feet firmly planted in the incredible engineering happening right here on Earth. If you've ever used a map app on your phone and wondered how the satellite systems actually get up there, or how Europe coordinates its massive off-world ambitions from Jupiter's moons to low Earth orbit, you're in the right place. We are breaking it all down today by looking at the incredible scope of the European Space Agency, commonly known as ESA. You see, everything ESA does is driven by one core mission, and it unites 23 different member states. It's not just about exploring the unknown just for the fun of it. It is fundamentally about making sure that the massive investments required for space travel actually return tangible, real-world benefits to the citizens of Europe, and by extension, the entire globe. To really grasp how ESA pulls this off, we've organized their operations into 4 main pillars. We'll be looking at Europe's gateway to space by covering science and space exploration, protecting Earth from above, Earth applications and navigation, and finally, enabling space transportation. So, let's dive into the first pillar, science and space exploration, where the goal is quite literally unlocking the solar system. What does this branch actually do? Well, science and exploration is totally dedicated to exploring our solar system and unlocking the fundamental secrets of the universe. And they achieve this massive goal through a highly coordinated mix of autonomous robotic missions and crewed human missions. We are talking about gathering billions of data points all across our cosmic neighborhood. You have the JUICE mission heading out to study the hidden oceans of Jupiter's icy moons, Euclid mapping the dark universe, the Solar Orbiter getting dangerously close to our sun, Bepi-Colombo charting Mercury, and ExoMars hunting for signs of life on the red planet. It is an amazing lineup. But, it's not just robots out there. Human ingenuity is absolutely key. ESA has a phenomenal roster of astronauts, including familiar names like Samantha Cristoforetti, Thomas Pesquele, and Luca Parmitano. Recently, ESA astronauts actually collaborated with Airbus to achieve the very first metal 3D printing in space on the ISS. This is a massive breakthrough. It means future crews won't have to wait for a supply ship to fix a broken tool. They can just print it right there in orbit. Okay, moving on to Pillar 2, protecting Earth from above. This is all about space safety. First up in the safety category is asteroid defense. ESA actively monitors near-Earth objects using the bug-eyed Fly-Eye telescope to catch early warnings of incoming space rocks. But they don't just watch, they act. The Hera mission is designed to study and test actual asteroid deflection strategies. It's essentially playing a high-stakes game of cosmic billiards to knock threats off course before they get here. Now, contrasting the natural threat of asteroids is the very human-made threat of space junk. Out in orbit, even a tiny fleck of paint traveling at thousands of miles an hour can be absolutely deadly to active satellites and astronauts. ESA is taking this incredibly seriously through their Clean Space Initiative and the development of zero-debris technologies. They're looking at ways to refuel, refurbish, and safely remove dead satellites from our increasingly crowded orbital highways. Then there's space weather. It might sound completely harmless, but violent solar storms can actually overload and fry power grids and communications down here on Earth. To combat this hidden hazard, ESA is developing the Vigil mission. Vigil is designed to keep a constant watch on the sun, acting as a crucial early warning system before those dangerous solar storms can strike our planet. Let's transition to Pillar 3, Earth applications and navigation. This is where we see space being used to directly benefit citizens. This branch is entirely focused on delivering earthbound benefits. Honestly, if you've checked the weather today, used a GPS app to find a restaurant, or connected to satellite internet, space is working for you right now. ESA uses orbital infrastructure to meet our immediate and future challenges in climate monitoring, connectivity, and navigation. Let's look at some key programs. Copernicus is an absolute titan of Earth observation. It essentially acts as Earth's doctor, constantly taking our planet's vital signs to monitor climate change and the environment. Then you've got Moonlight, which is pushing the boundaries of connectivity all the way out to the moon, and Argus, which focuses on advancing highly secure satellite communications. And of course, satellite navigation. Galileo is Europe's premier global navigation system, while EGNOS fine-tunes that accuracy. But they're also looking to the future, with experimental missions like Celeste, which recently broadcast a navigation signal from a low Earth orbit. Plus, they're advancing critical programs like Genesis and Navis-P to make sure the continent stays on the cutting edge of location technology. What I really love here is that these systems are never static. They're constantly evolving. For instance, Galileo signals have recently been updated specifically to support the exploding Internet of Things market. Furthermore, they're actively testing inter-satellite links for the second generation of Galileo. This means these satellites will soon be able to talk directly to one another up in the sky, which is going to greatly enhance the system's overall accuracy and resilience. Finally, let's explore Pillar 4, enabling space transportation. This focuses on accessibility and future tech. The enabling and support branch is really the backbone of the agency. Their job is making space accessible, handling all the behind-the-scenes engineering, the rigorous testing facilities, and the incredibly complex ground operations that make every single mission we've talked about possible. Europe maintains its independent access to space through powerful heavy lifters like the brand new Ariane 6 and the Vega launch vehicles, which take off from Europe's spaceport down in French Guiana. But they are also deeply invested in reusability. They're developing the Space Rider, which is an incredibly cool, uncrewed, robotic space plane designed to launch into orbit, do its job, and return to Earth, bringing its valuable cargo safely back home. But remember, before a rocket ever launches, the mission has to be built and tested. They utilize concurrent design facilities. These are essentially high-tech digital war rooms, where engineers can rapidly prototype spacecraft together in real time. When you combine that with funding for advanced concept teams and test firings at a brand new green chemical propulsion lab, it ensures that the future of European spaceflight is not only highly advanced, but increasingly environmentally conscious. So what does this all mean? We've covered a lot of ground today, but consider this. As ESA continues to blur the line between deep space exploration and everyday infrastructure, how long will it be before the technology keeping astronauts alive on the moon is the exact same technology running the power grid in your hometown? The world around us is filled with extraordinary engineering, and sometimes you just have to keep looking up.